So in this video we're going to be looking at what's called natural logarithms. Now let's review what's gotten us to this point. So earlier we've talked about just common logarithms. That's when we have a base value of 10. We talked about logarithms with other bases. And now we're going to look at, well, what happens if we have a logarithm with base e? Remember that value for e that we talked about earlier on in this chapter when we were dealing with situations that involved something being compounded continuously. That's where we first saw this value of e. Well, remember, e is just an irrational number, just like pi, so that could be the base for a logarithm as well. Now, when we have e as a base for a logarithm, we call this a natural logarithm. And we have a short way to write this because remember back when we talked about common logarithms with the base 10, we said a better way to write that is just as a log of x. So when we see that there's no base down here, we know it's a common logarithm. We know it has a base of 10. Well, instead of writing it like this, where we have log base e of x, the way that we're going to write our logarithms when we deal with the base e, our natural logarithms, is using an L and an N. Now that's an L, not an I. It's an ln of x, so the natural log of x. Now you want to make sure that you know how to use this button on your calculator. So on most calculators, you'll see either capital letter ln or lowercase ln. If you're using the CAS calculator, you're going to want to look for this button that says e to the x power, and right above it, you'll see ln. So you need to hit Control and then e to the x to be able to access that ln option. So why don't you guys go ahead and try natural log of 100 and make sure that you can get this correctly on your calculator. So if you do that, you should get, for this one, 4.605. Make sure that you know how to round in here as thousandth. That's 3 numbers after the decimal. So make sure that you know how to be able to access that, because we're going to need that for parts of this lesson. Now we're going to skip. We're not going to do my book notes. We're going to do these other notes here because I think this will be more appropriate for your assignment. Because in your assignment you're going to see problems just like this. So make sure that you write these down in your notes. And let's look at how we do some of these. So a lot of this is going to be very similar to what we've done in previous sections, because the only difference is that we have a base e. So otherwise, since we're dealing with logarithms, the process is going to be the same. So here we have logarithm equations. We're going to write these as exponential equations. So remember, to write it as an exponential equation, we have to drag the base over. Well, the base here we don't see. If you want to write down the base, if you want to write it down like this, you can. So then you can see what the base is that you're going to drag over. So we see that we have a base e, so we're going to drag that base over. So your answer would be 1.5 is approximately equal to e to the 0.405 power. And you're not going to do anything to solve here. We're just rewriting this to be an exponential form. So that's your answer. So this one, remember, you don't have to rewrite the log base e. You don't have to write it like that. You can just remember that if you see a natural log, it means that it has a base e. So we can drag that base over. So your answer here would be 3,000 is approximately equal to e to the 8.006 power. There's your answer. Now we're going to look at how to write something as a logarithmic equation. So if you haven't done so already, make sure that you get this in your notes. So we're going to look at these two examples. So in this first example, again, these are written already in exponential form. We're going to go backwards from what we were just doing in the last example. We're going to put these in logarithm form. So remember, when we put something in logarithm form, we write it as the log, and then this is your base for your logarithm. So it'd be log base e. But remember, a better way to write log base e is as a natural log. So here we have the log base e written as the natural log of the value, which is 4.482. That's approximately equal to, just like before, all logarithms are equal to exponents. So our exponent here is 1.5. So the natural log of 4.482 would be about 1.5. So why don't you see if you can try this one on your own. E to the 7/4 power equals 5.755. Why don't you try that? So you should have gotten that as your answer. The natural log of 5.755 is approximately equal to 7.4. Or I'm sorry, 7/4 as your answer. Okay, so that's just the basics, knowing that how to change something from logarithm form to exponential form or vice versa. Now we're going to look at how to do these without a calculator. Now in the next lesson we're going to learn a little rule that will help with some of this, but I'll tell you that rule now. We'll give it away. So in that way, in the next video, it'll just be more review for that one particular rule. And that rule is this: if you ever have a base for your logarithm, and it shares the same base as the value that we're taking the logarithm of, your answer is the exponent. So in other words, remember here we have the natural log of e. Remember, this means that you have a logarithm of base e. So the bases are the same. So if the bases are the same, your answer is just going to be 8. The reason for that is because, remember, with the base e, we're trying to figure out what exponent you'd apply to e that would give you e to the 8th power. Well, the exponent you'd apply to e would be 8. So your answer would just be 8 here. So let's look at the next one. Natural log of e to the 0 power. What do you think that would be? Well, you should have said 0 would be your answer, and if you said that, you are correct. But now this is going to get a little trickier. Here we have 5 times the natural log of e squared. What I want to do is I want to simplify this part first. The natural log of e squared, just like we just said, since it has a natural log as a base e, and this e are the same, your answer is the exponent, so that's just going to be 2. And 5 times 2 gives me 10, so my answer for this one would be 10. Let me rewrite this one. This is 7 times the natural log of e to the negative 3/7. So here you're going to take 7 times the exponent, which is negative 3/7. The reason why, again, we can do that is because a natural log has a base e. So what exponent would you apply to e to get e to the negative 3/7? It would just be the negative 3/7. Or remember that shortcut, whenever the base is the same as the base that we're taking the value of, your answer is the exponent, so negative 3/7. But we multiply these together. When you multiply these together, the 7s would cancel out, leaving us with negative 3 as your answer. Why don't you guys attempt the next one on your own, and we'll check that in a second. Okay, what you should have done here is you would have had 5/3 times, this would just be 3. And 5/3 times 3 would be 15/3, or 5, or you can look at it this way and say that the 3's would cancel out, so your answer would be 5. So those are some simple ones to do without a calculator. Let's look at some story problems. Remember back in earlier in this chapter, we heard this phrase, compound continuously. That's where e was first introduced to us. When you see that phrase, remember it's this formula, PERT. A equals P times e to the RT as your exponent. So let's read this one. It says, if you had $10,000 to invest in a savings account that earned 5% compounded continuously, how many years would it take for the account to be worth $15,000? So in this scenario, we know our principal is $10,000. So our 10,000 is going to be our value for P. Our 15,000 is what we want to earn, so that's going to be your total amount. Whoops. So it'll be your principal, which is $10,000, times E. Your rate we know is 5%, which we never use. Remember, don't forget, we never leave a percent as we see it. We always need to change it. In this case, since it's a rate, we're going to change it to a decimal, so it'll be 0.05 times time. And you're trying to figure out what t is. Now, when you're going to solve these equations, notice how we have an exponent that's a variable. That we're trying to figure out what t is, but it's up there as our exponent. So there's going to be 3 steps that we're going to do to solve this. The first step is to get the base by itself. And the base in this case is e. We want to get that e by itself. Once we do that, the second step is to write it in logarithm form. Or in this case, since we're dealing with e, it's going to be written as a natural log. And the last step is just to solve it. So let's look at how we would apply those steps to this one. So again, we want to get this e by itself. So I'm going to divide both sides by 10,000. So when we do that, we get 1.5 equals e to the 0.05t as your exponent. So the next step, so we have our e by itself, so the next step is to write it in logarithm form. Because right now we're stuck. We don't know what to do because we have a variable that's an exponent. So earlier on in this chapter, we didn't know how to solve these types of problems. We couldn't figure out what the time would be for it to take to get to this value. We would have had to guess and check, or maybe even we could do this by graphing, I suppose. But a better way to do this is with logarithms. So we're going to put this in logarithm form. So it's going to be, this is like what we were doing earlier in one of those examples where we change the form it's in to be in logarithm form. So it's going to be log base e. But remember, log base e is the same as the natural log of our value, which is 1.5, equals, remember logarithms are always equal to exponents. Our exponent is 0.05t. So to find out what t is, we divide both sides by 0.05. Now when you do that on your calculator, you're going to get a decimal as your answer. Let's see, you get natural log of 1.5. Doing that on my calculator. You should be doing this on yours as well. Divided by 0.05 gives us 8.11. Or about 8 years is how long it would take for you to go from $10,000 to $15,000. We're going to look at one other type of example that you're going to see in your assignment. We're going to do the same process, the same 3 steps that we just did in the previous one. So actually, let's bring this down here. Whoops. Okay, so let's look at the story problem. It says, what annual interest rate compounded continuously is necessary for an account to quadruple in 20 years? And then it asks a follow-up question and asks us how much, what interest rate we would need for it to quadruple in 30 years. That's what that means. Okay, so our first step is to set up our equation. We know that it's going to be compounding continuously again. So it's going to be in the form a equals p times e to the rt. But they don't give us much information, but they do tell us it's going to quadruple in 20 years. And we want to figure out what the rate would be. Now, if it quadruples in 20 years, that means we want the total amount to be 4 times of what we started out with. And our time would be for 20 years. So now we're going to still follow these 3 steps. We're first going to start by getting the base, which is e by itself. I'm going to divide both sides by p. Doing so gives me 4 equals e to the, I'm going to write this as 20r. So now I want to write it in logarithm form. So instead of log base e, it's going to be the natural log of our value 4 equals 20r. Divide both sides by 20 to get the r by itself. And this is the equation that we have. I want you guys to type this in on your calculator. So I want you guys to go ahead and do that right now. And the reason why I want to make sure that you do this on your calculator is because I want you to see what we're going to do with this answer. So you're going to take the natural log of 4 divided by 20. Now when you do that, your calculator gives you a decimal, 0.069. Technically 0.0693, but we'll stop after 0.069. Now remember, this is a rate, so we want to make sure that we write our answer as a rate. So our rate would be 6.9% in this case. Now, here's the deal. They ask us a follow-up question now that asks, well, what rate would we need if we wanted to quadruple in 30 years? Well, everything in this whole problem would be the same. The only difference is that our time would be 30. So all the way down to here, it would be the same equation. So what we would do is we would take instead, we would take the natural log of 4, because it's being quadrupled, divided by 30. And this time when you do that, you get a smaller percentage rate because it's going to take more time. So you get 0.0462, which we can round as a percent, would be 4.6%. So you're probably more likely to get an interest rate at that rate of 4.6 than 6.9, so it's more likely for you to quadruple your money in 30 years than it would be in 20 years. So that is how we use natural logs. So if you print out your assignment from Moodle, you'll see that some of the story problems on the back are very similar to what we just did. So you should be able to do just fine on that assignment. So with that, good luck.